Alright, so today we're on day 5 of Unit 1 on solving linear inequalities. And this is Unit 1, Lesson 4 on the video and notes. And so then we're going to focus on reviewing solving inequalities. So today we're going to solve linear inequalities. Just like yesterday, we're going to follow the same rules. First thing we're going to do is we're going to distribute. And then we're going to simplify the expression. And we do that by gathering or combining like terms. Move the variables to one side, move the numbers to the other, and you solve for the variable. Now, in inequalities, do not forget, if you multiply or divide by a negative number, you are going to flip an inequality. So if it's, and we'll talk more about that. And then the last thing is you analyze the solution. And we talked about that yesterday. If you come up with two numbers at the end, if the statement is true, that's all real numbers. If the statement is false, that's no solution. So remember when we talked about that. Quick background knowledge. We have 4 types of inequalities. We have less than, we have greater than, we have less than or equal to, and we have greater than or equal to. Now, some other ways that they can word this. They could say fewer than for less, or they could say more than for greater. Here's where it gets really confusing. If it's less than or equal to, it is also what we call at most. So if I say you have less than or equal to $6, at most you could have $6, or you could have no more than $6. If I say the amount of money that you have is greater than or equal to $6, you have at least $6, or no less than $6. So that's kind of some confusing ways that they'll put it so that you can still understand the same concept. So and think of it in terms of money. If I say that the amount of money you have is less than or equal to a certain amount, that's the most you could have. If I say the amount of money you have is greater than or equal to a certain amount, that's the least amount of money you could have. And that's kind of the way that helps me remember it. The way we graph these on a number line, you've done this before. For less than, I shade to the left, and it's an open circle. For greater than, it's an open circle, and I shade to the right. Less than or equal to, it's a closed circle, and you shade to the left. Greater than or equal to, it's a closed circle, and you shade to the right. Okay? So, some quick practice. Should be a review of what you did yesterday. You solve, so we add 7. And so x is less than 3. So it says solve and then graph. So I'm going to make a little graph here. I'm going to put the number 3. And since it says less than, I'm going to open the circle and shade everything to the left. And that's all I want you to do. So go ahead and do these 2 problems. And this third one too. And then we'll go over the answers. Okay, these 2 were tough because when you got your answer, 2 is less than x. Well, if you put 2 here and you put an open circle and you shaded left, that's fine. But really what this is saying is 2 is less than x. So x is greater than 2. So you had to shade to the right. This one was tough because you had double negative. So you had to put a positive 7, which means you had to subtract 7. And you end up with negative 15 is greater than or equal to x, which means that x is less than or equal to negative 15. And there you go. This one actually ended up being the easiest because you just had to do 3 minus 2 1/3. and you end up with x is less than or equal to 2/3, and then there it is. When we multiply, do not forget, when you divide by a negative, you flip the sign. So when I divide by -7, it becomes x is greater than 2. So I put a 2, open circle, shade to the right. Now, here I'm dividing by 1/4. The number one mistake that is made is everybody sees this -1 and assumes they have to flip the sign. Remember, it's when you divide or multiply by a negative. Not when there's a negative already there. It's when you multiply or divide by a negative. So this ends up being x is less than or equal to -4. The sign stays the same. Same thing here. I'm dividing by a negative. The sign's going to flip. X is greater than or equal to -8. Here, I'm multiplying by a -3. So 6 is greater than x, or x is less than 6. We're going to skip this slide. We'll do it tomorrow in class. Just put a star right there beside those two problems. Here's what I want you to do. I want you to pause the video, and I want you to use the rules that we talked about yesterday in equations, and I want you to solve these, okay? And once you've solved them, I also want you to graph them. So you're going to do these 4 problems on this page. So I want you to follow all the rules that we learned about yesterday, solve, and then graph. Okay, so I asked you to pause the video and answer these 3 questions, so hopefully you've done that. Alright. For the first one, I divided by -2, so that made me have to flip the sign. X is less than -12. For the second one, I did not have to flip the sign. I just had to make sure that I distributed this negative to give myself a -4 here. If you had made one mistake, I'm assuming that's where it would be. And so then x is less than -11, -11 and 1/3. And this way, really straightforward. K is greater than or equal to 8. And in this problem, I had to distribute both. And this is what I did. I decided I didn't want to have to flip the sign. So I did not put the 3 over here. I put the -5 over here so that I got -8 is less than or equal to 8g. Then when I divided by 8, I got -1 is less than or equal to g, and then I could just flip it and get g is greater than or equal to -1. Alright. Do this one in preparation for class tomorrow, and we'll check this as a group. And it's what I'll be checking to make sure you did your notes. And then also, so now we got to talk about special solutions. Just like what we had earlier, yesterday, we're going to have the same thing happen today. When I move the 3x over, the 3x's cancel out, and I'm left with 4 is less than 10. We know that's true. We'll come back to that in a minute. When I do this one, the -3x's cancel out, and I'm left with 6 is greater than 15. Hopefully you remember yesterday what I said. If a statement is true, it's all real numbers. If a statement is false, it's no solution. So is 4 less than 10? Yes, this is what we call all real numbers. Is 6 greater than 15? No, this is no solution. To help us out remembering that, if the variables cancel and you are left with a false statement, the answer is no solution. And that's this symbol. If the variables cancel and you are left with a true statement, the answer is all real numbers. And that's that symbol. And that applies to equations and inequalities. So make sure you understand that, like if you get a special solution. If it's false, it's no solution. If it's true, it's all real numbers. Your classwork for today is the review of solving inequalities. Go ahead and, like I said, do odds or evens for all 3 pages, all 4 pages. And then, you know, when you're done, I'll check it off with you, and we'll be getting ready to move on to the next topic. Actually, after this, go ahead and when you're finished with this, and I'll check you off, and I'll remind you of it in class, you're then eligible to go ahead and start the quiz for Unit 1. The quiz is open notes. Some of it might be a review of like number sentences, and I'm going to be covering that in the next lesson, but certainly if you want to start the quiz, you're able to do so. And like I said, it's all open work, so make sure you've got your notes straight and your work done. Any questions, see me. If not, I'll see you in class tomorrow.